Right, well, the room has hushed. This is the first time, 2 days beyond my allotted term, 2 days into extra time, that I've actually been able to address a real live audience of people in our lecture theatre. Previously, I've had to get used to peering at cameras and screens and so on. So it's a real delight to be able to address people personally. And as I've said before, there's only one thing worse than addressing an audience like this, and that's addressing something that's a non-audience. So, continuing the sort of sporting theme, this is a game of two halves. So what remains of this morning will be Phil Peel's presidential address, and then this afternoon we have the various awards, the Vision Awards, the Special Awards, and the Prestige Awards. And at half-time, we have lunch downstairs in the Marble Hall. It's extravagant, so I'm told, but not so extravagant that it embarrasses Phil, who is still currently our Finance Board Chair. And Phil, it's very good to see you. I'm glad you've been able to come, and I hope, and you're still smiling 2 days on. That's which is even better. Phil is the 137th president of this institution, so following in a long line of people, many of whom actually, or some of whom, shall I say, not many, but some of whom are here in the room today. Phil, as I do, comes originally from the Wirral, so it's good to keep the job in the family. Phil has been a member of this institution since 1981 and a fellow since 2007. He did engineering science at Durham University. So he got a BSc in 1986, and he went on to do an MSc in turbo machinery in the following year. And he's worked in the field of turbo machinery, steam turbines, power generation, and those type of that industry ever since. So his career's focused on the design and development of large-scale steam turbines. So he began, in fact, with what was the British version of General Electric Company in Rugby after he left university. That later became Alstom Power. And in 2001, he moved to Baden in Switzerland. And that, for those of you who are interested in the history of engineering, that's where the Brown Boveri company got started. I think Walter Bavary was Swiss. Charles Brown was British or Scottish. And so, Phil, you've followed very much in the footsteps of the founder of Brown Boveri. And I did visit there once myself. I worked for ABB, Assea Brown Boveri, for a number of years. And I do remember going to Baden on a business visit. And Phil is now chief engineer, and the business is now owned also by General Electric, but this time General Electric from the United States. His journey as an IMechE volunteer started as a school's liaison officer in the 1990s. But he was very instrumental in setting up the Swiss branch or section, as it were, of the institution. And got it going and chaired it from 2011 to 2016. And at the same time, he was on the International Strategy Board and so on. He joined the trustee board in 2016, initially as an international member, and then subsequently as vice president and so on. And during that period, he's had a go, actually, at most of the committees, from what I can make out, looking down the list: Technical Strategy Board, Legal Committee, Qualifications and Membership Board, Audit and Risk Committee, Commercial and Investment Board. But the area in which I've had most dealings with Phil is on the finance side of things. He and I and one or two others were involved in the review work we did 2 or 3 years ago. And as a result of that, we set up the Finance Board, and Phil has chaired that ever since. So that's an interesting and impressive background. The other point, of course, is that Phil is the first internationally based president that we've had after 136 previous attempts. Phil is joined by Gillian. So I suggest you look at him closely, because you may not see much of him for the next 12 months. Oh, well, okay. They have two children. They have a daughter who's also in Switzerland, and actually I think you've got a granddaughter now, in fact, and a son who's based in sort of Copenhagen. And the title of Phil's address is Building the Future. So over to you, Phil.
So to take Peter's analogy with football, we will now start the first half, blow the whistle, with my presidential address. Ladies and gentlemen, a sincere welcome to all of you here today, both those here in our prestigious headquarters building in London, as well as all those who are listening in virtually. And I sincerely hope we don't have any technical hitches with the IT today, as we did on our annual meeting on Wednesday, so bear with us, please. In my presidential address today, I start by celebrating the 175th anniversary of our institution. I provide some background on my decision to enter engineering as a career and draw on the over 35 years of experience that I have in the power generation market, considering recent developments and new possibilities. Finally, I reflect on how we can build the future of the institution so that it is well placed for the new challenges that the next 175 years will bring. In this, our 175th anniversary year, I am delighted to have been elected as the 137th president of the institution. And in the institution's 175th anniversary year, we have good reason to celebrate. It is a wonderful opportunity to recognize the achievements of the IMechE and the contribution of mechanical engineering to society, whilst also inspiring the future generation of engineers. We have already made a great start to our celebrations, with Sir Patrick Vallance delivering the keynote speech on the 175th anniversary date itself in January this year. Praising the mission of the institution, he said, "Just as it was in the mid-19th century when this institution was formed, engineering in all its guises remains absolutely central to solving the big challenges of the day." The institution has certainly come a long way since its foundation, as the timeline on the slide contests. The formal foundation of the institution took place in Birmingham on Wednesday, the 27th of January, 1847, when the founders met in the Queen's Hotel. That location now sits on the site of the construction project for the new HS2 rail terminus. The institution's early history was marked by the rapid expansion of the railway network throughout the UK mainland. So I think it is fitting that HS2, the latest UK rail development project, should have chosen that location as the site for the new Midlands rail terminus. I'm also delighted to announce that Birmingham will be the location of our 175th anniversary annual dinner later this year in November. It is appropriate that we should return there this year and celebrate together the events of 175 years ago that launched our fine institution. As the theme of our campaign, we have chosen forward thinkers. Forward thinkers are engineers who make a difference to the world. Forward thinking implies breaking away from the rest of the crowd, not feeling trapped by conventional thinking, and moving forward with vision and conviction. This year, we focus on how mechanical engineers can help solve the global challenges we face today, and the support of our members is critical in promoting these. I would encourage you to continue to support our campaign within your own schedule of events and activities. Also, if you've not yet had the opportunity to view it, I would strongly recommend taking a look at the excellent video featuring Lucy Bonner, our archivist, where she uncovers her research into the founding of the institution. It is right to look back with pride at our achievements over the first 175 years of the institution's existence. In the words of Lucy, we aim to celebrate and honour our past whilst looking confidently towards the future. Later in my address, I want to take some time to focus on how we can build together the future of the institution. But first, a few words of personal introduction. I was born in the severe winter of 1963 in Birkenhead on the Wirral. As Peter's already mentioned, we need to plug the Merseyside as much as we can, in the northwest of England. As my mother ruefully recounts, the snow was so deep, and for those who recollect that winter, it was pretty severe. The snow was so deep that I didn't go out in my pram for the first time until the thaw set in months later. Growing up, I was always fascinated by mechanisms and understanding how things function. If something needed fixing, I was generally the one in the house that was given to sort it out. A solid grounding in Lego and Tonka toys certainly helped. I have to say that this was a positive advantage as a child in remaining in the good books of my mother. And I would recommend that you always remain in the good books of your mother. She would regularly deliver me, challenges that demanded my attention, and was clearly delighted when the device that had previously been broken and non-functional was returned fixed and in good order. I was also influenced at an early age by engineering. As we see on the slide, my maternal grandfather was an electrical engineer and helped to keep the West African gold mines functional during the Second World War. He enjoyed the challenge of turning his hand to new things. In the post-war era, he worked for various UK electrical supply companies, names such as ManWeb, Merseyside and North Wales Electricity Board, and SWEB, South Wales Electricity Board, that are no longer with us, remain a clear memory from my childhood. The left picture shows him in his position as the branch manager of the SWEB Cardiff offices in 1960. So it was perhaps no great surprise when I myself decided on a career in engineering. As Peter has already mentioned, I spent 4 very pleasant years in the north of the England, attending the University of Durham, where I secured my bachelor's and master's degrees. My first step in my own engineering journey started immediately after my schooling, however, when I embarked on a pre-engineering year, known at the time as a 131 sandwich course, as a student apprentice with the UK Ministry of Defence. I was stationed for the first year at their Aeronautical Quality Assurance establishment at Harefield, Middlesex, which also hosted an apprentice and student training school. I found this initial grounding in workshop fundamentals extremely valuable, and I have often looked back on this experience as establishing some of the foundation stones of engineering principles that have held me in good stead throughout my career. After my university studies, my own professional engineering career kicked off down the road from Birmingham in Rugby, where I joined, as Peter's already mentioned, GEC Turbine Generators, as a graduate engineer working on steam turbine blading design. My engineering journey has been firmly grounded in the global power business ever since, more specifically, steam turbine development and design. More on the power business, however, a little later in my presentation. If you could firstly perhaps allow me a short aside. As you now know, I live in Switzerland, and I moved there to work over 20 years ago. This year, another organization is also celebrating its 175th anniversary, namely the Swiss Railways. The inaugural line, located entirely on Swiss territory, opened on the 7th of August, 1847. Shortly after 11:30 a.m., the arrival of the first official train in Zurich was announced with a gun salute, I doubt that they would be permitted to do that nowadays. In the present age, we are used to rapid transport possibilities, but the creation of this new line at the time must have been seen as an engineering marvel and dramatically reduced the time of a carriage ride for the 20-kilometre journey from 3 hours down to just 45 minutes. The locomotive number 1, Limmat, similar to the one in the picture, brought the invited guests and members of the local canton authorities from Baden to Zurich. After celebrations and sightseeing of the train station infrastructure, the train, with 140 invited guests, left Zurich for Baden at 1 o'clock prompt. After all, they had the Swiss reputation for punctuality to uphold. Scheduled operations started a few days later. Soon after the opening, the line began to be called the Spanish Brötlibahn, which translates as the Spanish Bun Railway, because the Zurich gentry sent their servants by train to buy the buns in Baden in order to impress their guests at Sunday breakfast. Previously, their poor servants had to set off from Baden by foot at midnight the previous day to reach Baden in time to buy the buns there, because they, according to the canton laws, they were the only place that they could be fabricated. So as to the name, the buns were apparently derived from buns made in Milan during the 17th century, which then at the time was still under Spanish control. So there we are. If you have a Trivial Pursuit question about Spanish Brötlibahn, you've got the full history now. The institution's first president, George Stephenson, as we see in this very impressive picture of him on the wall, was instrumental in supporting the early railway development in Switzerland. And his son, our second president, actually came to Switzerland in 1850 to help plan the country's railway system. Their influence on European network development was significant, and in addition to adopting the Stephenson standard gauge of 1.435 metres, the standard of left-hand traffic, the norm in the UK, is also a legacy in many mainland European countries, including Switzerland. This proud railway engineering heritage is continued today through the institution's railway division. Whilst on the subject of Switzerland, another pioneer British engineer, Charles Brown, and this is where Peter's stolen this slide, but okay, I shall repeat it anyway. Another pioneer British engineer, Charles Brown, began building steam engines at Sulzer Brothers in 1851, and 40 years later, he partners with Walter Boveri to form the Brown Boveri Company, the predecessor of the company where I currently work. I've been involved in this sector of engineering for the whole of my professional career, and I have greatly enjoyed the experiences it has provided. I've seen significant changes in it over time as the focus on key fuel sources has shifted. One of the senior engineers in the design team, where I first started, described the combination of the enormous equipment scale linked to the extreme precision needed for its components as supersized watchmaking. It has fascinated me ever since. Steam power has been widely used throughout history as a means of power. As early as around the birth of Christ, simple globes filled with water and heated to drive out steam and cause their rotation were being described by people like Vitruvius and Hero of Alexandria. The fundamentals of Hero's design, based on the written description he has left behind, are shown here. However, these devices were really no more than novelties and not a practical source of power. It was not until the Industrial Revolution that steam engines really came into their own. From the initial basic steam engines of Newcomen and Watt in the 18th century, development progressed to the multiple-cylinder compound engine designs of the late 1800s. However, by the end of the 19th century, piston-driven reciprocating steam engines had largely run their course and had started to be replaced by steam turbines. Perhaps if you would just allow me a slight aside, and I can refer to the first proceedings paper that the institution ever published, almost exactly 175 years ago. A short treatise by a gentleman called William Buckle on experiments on the fan blast. One might even refer to it as a blast from the past. Within his paper, Mr. Buckle comments on a sequence of experiments he had conducted to improve the effectiveness of blast furnace performance. One statement is of particular note, and one that will strike a chord with all engineers striving to optimize the performance of their systems. If I may quote, "It is hoped that the hints here thrown out may be serviceable in leading to such constructions of the fan as shall ensure the greatest useful effect with the least expenditure of power. I've spent my professional career trying to apply that maxim to the efficiency of large steam turbines and helping to optimize the mechanical and thermodynamic performance of the largest power generation equipment on the planet." A steam turbine functions in its simplest form in essentially the same way as windmills have for centuries. A surface can be profiled in such a way that the medium flowing over it causes a differential pressure to form from one side of the surface to the other. If coupled to a common shaft, such surfaces can produce rotary motion. In the case of steam turbines, the working medium is pressurized steam, but not steam as we know it commonly when we boil the kettle for a cup of tea. The inlet conditions to a first turbine section of a modern steam turbine achieve pressure levels up to 250 times atmospheric and superheated temperatures beyond 600 degrees centigrade. The energy potential of such a medium is colossal if it can be harnessed in a controlled manner. And it was not until the 1880s that the practical challenges for capitalizing on this simple principle were overcome by one man, the Honorary Sir Charles Algernon Parsons. He saw that the best approach was to expand the steam gradually over a series of axial stages so that each stage was able to function close to its optimum efficiency. I think he must have had some discussions with Mr. Buckle in that regard. He promoted the turbine as a smaller and more efficient alternative to the steam reciprocating engine. His first turbine from 1884, which can be viewed in the London Science Museum, was immediately successful and keenly viewed by the fledgling electricity generating industry as a viable prime mover for their electrical generator sets. An early sketch by Parsons, as we can see on the picture, showing the basic blade design of his adopted reaction principle solution, is also displayed in the Parsons room of this Birdcage Walk building. The success of Parsons' ideas led in 1888 to the first use of a steam turbine in a commercial installation at the Forth Banks Power Station in Newcastle upon Tyne. A year later, Parsons set up his own company, C.A. Parsons and Company, to supply the ever-growing worldwide demand. His machines were the forerunners of the turbogenerators that today power the creation of most of the world's electricity. It is not an exaggeration to claim that our life today will be very different if the steam turbine, with its capacity for generating enormous electrical power efficiently and in a compact installation, had not been invented and developed. If I can just reflect on a few of the words of the 81st president of the IMechE, Baron Hinton of Bankside, a respected figure in the British nuclear power industry and the supervisor of the construction of Calder Hall, the world's first large-scale commercial nuclear power station in the 50s. He is attributed with two definitions that most engineers can relate to. Firstly, engineering is the science of knowing what you can get away with. And secondly, progress is getting out of the trouble you would not have been in if it had not been for progress. In his Parsons centenary paper of 1984, Frank Harris, a former chief engineer of GEC turbine generators in Rugby, where I worked as well, described the major advances that had taken place over the first 100 years since Parsons' invention. At that time, the most widely used fuel source was coal. However, concern about the levels of emissions of greenhouse gases from the burning of fossil fuels has had a dramatic effect on the current focus of new power generation projects. But the days of steam power generation are not over. In addition to operation of legacy plants, it remains the technology of preference for low-carbon nuclear projects. With an increase in power plant retirements by 2030, the UK faces a critical challenge to stabilise energy production. After COP21, the UK made a significant decision regarding its energy policy to move forward on a low-carbon economy. Since 2010, 25% of the UK's nuclear electricity generation capacity has been cut due to decommissioning of old plant. And by 2030, a further 40% is expected to close. The call for new nuclear energy has been answered in the UK by the Hinkley Point C, or the HPC, new build nuclear power plant. When complete, HPC is expected to deliver 7% of the UK's low-carbon energy for the next 60 years. The plant is projected to supply over 3.2 gigawatts of power to the grid, enough for 6 million homes and efficient enough to avoid 9 million tonnes of CO2 emissions every year. To power HPC, the two largest steam turbines ever to be built, each longer than an Airbus 380, are in the process of being installed. The plant's two turbo sets will each supply 1.6 gigawatts of net electrical power into the UK grid. Including in the steam turbine design, as we can see on the slide, are 3 double-flow low-pressure steam turbine modules, incorporating the longest last-stage blades ever produced at 1.9 meters or 75 inches aerofoil length. Each bladed low-pressure rotor weighs about 300 metric tons and spins at 1,500 RPM or 25 revolutions per second. At rated speed, the centrifugal load on each last stage blade is roughly equivalent to the launch weight of an Ariane 5 space rocket. To appreciate the scale, I like to run a short video, courtesy of General Electric, showing the HPC low-pressure rotor manufacture and testing at one of their manufacturing facilities. got your foot tapping. So and my thanks to General Electric for permission to use the video today. If I can move now on to look at a different area of nuclear power, and that's the area of small modular reactors. Recent attention has been focused on smaller nuclear plants, where the modular approach can be adopted to drive down costs and fast-track approvals. The so-called small modular reactor configuration is still in its fledgling days, but it offers another approach to fission power and addressing future supply demands. Many countries have development plans for SMRs, but few have been constructed to date. It means there is work to do for governments as well as reactor vendors to build public awareness of the technology. I'm sure they will come. It's a question of really when, I think. But ensuring the public have confidence in the technology will be key to its successful rollout. If I can now switch to the renewables market, which has expanded massively in recent years. As a young engineer, I read about the early days of UK wind power pioneering at the Centre for Alternative Technology in mid-Wales. From humble beginnings, wind power has expanded to become the largest source of renewable energy in the UK. The UK is also home to the largest installed offshore wind farm in the world, Hornsea 1, located off the coast of Yorkshire, and larger farms are in the planning phase. The scale of the latest generation of offshore wind turbines is truly eye-watering, as demonstrated by the GE Haliade-X design. From base to tip, it stands at over 1/4 of a kilometre tall, or 80% of the height of the Eiffel Tower. With each rotation of its giant blades, a typical UK household can be powered for 2 days. The vast majority of wind turbines that are offshore are firmly anchored to the seabed, limiting the depth of water where they can be deployed. However, there is active development of floating tethered wind turbines for deep water applications. If we manage to successfully solve this major engineering challenge, extensive areas of the world's oceans could be opened up for wind energy exploration. And perhaps a look at the future. In the late 1980s, I remember visiting the Joint European Torus project, known as JET, in Culham, in Oxfordshire. I was impressed by the scale of engineering challenges that together the scientists and engineers were attempting to overcome. These challenges still remain, but it appears we are edging ever closer to turning the dream of commercial fusion power into a reality. Globally, as well as in the UK, interest in fusion energy is growing. The UK has a world-class and expanding research centre at Culham, and the International Thermonuclear Experimental Reactor in the south of France is in the advanced stages of construction and assembly. Private sector activity has also accelerated, with over 15 fusion energy startups being created since 2009, including Tokamak Energy, which the institution supports through its Stevenson Fund, and First Light Fusion. The industry as a whole is gaining momentum. The potential advantages of fusion have been known for a long time. A commercial fusion power plant would be a reliable energy source with an almost limitless supply of fuel, and would be low carbon and produce much lower levels of radioactivity waste than a nuclear fission plant would. Essentially, commercial fusion would have many of the low carbon advantages with few of their downsides. A recent report published by the institution and sponsored by Assystem provided a high-level assessment of the fusion industry and examines the current state and future projects of fusion. I strongly recommend a read of it. Fusion could potentially become the energy source of the future. But now, I would like to reflect on how we, as an institution, could build our future. Since 2021, our new strategy committee has been working actively to formulate our future strategy. Work is now focused on consultation and confirmation of the high-level strategy as we develop a more detailed implementation plan to deliver that strategy. Having a clear strategy is core to any organization's success. The Charity Governance Code for larger charities outlines that organizational purpose is the overarching principle that ensures trustee boards are clear about their organization's plans and aims and ensures that they are being delivered effectively and sustainably. The code states that a trustee board's core governance roles are to focus on strategy, on performance, and on assurance. Underlying our strategy are the 4 pillars that we have chosen for our values: inclusion, integrity, impact, and innovation. And to support implementation, we will use the leverage of a number of strategic enablers. These have been selected to drive our strategy forwards. Strategy will be a key focus area for the institution over the coming years, and I look forward to supporting its implementation during my presidential year. Our values and behaviours are a foundation stone upon which we need to execute our activities. As a result, the institution is actively implementing its diversity and inclusion strategy as outlined in last year's D&I report, A Case for Change. From mid-2021, staff and senior volunteers have been attending the first wave of training modules to heighten D&I awareness. I attended this first wave and I've been truly impressed by the standard of this training and the enthusiasm of the participants in having open and frank discussions. I stand behind the further deployment of the training to a wider representation of the membership and staff as we continue to roll out our D&I strategy forwards. Our total membership at the end of 2021 stood at around 112,000 in 140 countries, of which just short of 30% were resident, like myself, outside of the UK. The institution has a global voice, and one we should use more to influence the future of engineering worldwide. I'm encouraged by the recent growth seen in our international membership. Local volunteer interest and support is essential to expanding our global footprint further. Our recent manifesto, The Future of International Collaborative Engineering, articulates a framework for increased collaboration in tackling society's major 21st century challenges. I welcome such developments. I've been active with IMechE in Switzerland, as has been already mentioned, and involved in the launch of the IMechE Switzerland Group in 2009, holding the position of chair for several years. However, Switzerland is just one example of the international activities within the institution. The clear message is that non-UK institutional activities are active and are growing. Switzerland has a reputation for quality, reliability, and of course, chocolate, fondues, and army knives. But it also has a strong engineering history and base to which anyone travelling on the Swiss railway network can contest. From my experience in Switzerland, I have learned that international members generally want and will support a local institutional presence. But it is necessary to engage local members through regular dialogue and interchange. Local networks feed growth, but it's important to be realistic about expectations, especially during the early grounding phase. Mutual support within the local committee is important, as well as strong communication links back to HQ. I want to acknowledge and thank Ravi Blala for preparing the picture of Birdcage Walk that our 175th anniversary celebrations are using. The trustee board is in the process of formulating a resolution for members that will ask them to vote on the proposed future strategy for our headquarters building here at Birdcage Walk. As we have seen from the many discussions on this topic, it is clearly a very emotive subject for members. Regardless of your stance, however, the building is now over 120 years old, and it is in need of some essential maintenance work. Action is needed, and I hope we will have a clear direction of travel on the way ahead in the near future. However, today the focus is not just on our physical building, but also on our future engineering priorities. The UK National Engineering Policy Centre, led by the Royal Academy of Engineering, has identified 5 critical engineering priorities. Some of these areas of development were covered by the institution last year at our COP26 Hub event. Through our Learning Society activities, we are well placed to inform society and government on these critical areas. It is now over 2 years since the outbreak of the COVID-19 global pandemic, and the world is slowly recovering. Many thought it would be short-lived, and we would be able to return to a state of normality within a matter of weeks or months. That has sadly proved not to be the case, and many lives have been negatively affected. My thoughts and sympathy to go out to all those who have been impacted in some way by the virus. I would like to praise the work of our COVID task force and the Pandemic Infection Control Solutions, or PICS, task force, which have done such a tremendous job in managing the engineering support and advice we have provided during the pandemic. There are lessons to be learned for the future concerning more effective infection control, and I hope that the institution will be at the forefront of supporting their implementation. We cannot afford to be complacent in that regard. Important to me also is enthusing the young members. I had the pleasure of meeting young member Victoria Jones when I was at Birdcage Walk in March this year. She was on a visit to our headquarters building to have a look around. Victoria is an engineer at BAE Systems in Barrow, northwest England. And here's a picture of her in front of HMS Audacious. And I've taken the liberty of playing on words a little bit with regard to the caption. I hope you enjoy it. She started her career as a primary school teacher. However, she wanted a change, and she successfully applied for a project management position at BAE Systems. She started looking around the shipyard and spending time with the test and commissioning teams who were working on the commissioning of the Astute-class submarines. And there she discovered that she had found the job that she wanted to do, engineering. She moved on from project management to engineering at BAE Systems. It has involved her having to go back to school to get a qualification, and she's now in the process of actually working towards that qualification with a view to starting the process to become a chartered engineer. Thanks to Nick Hansen, who is Victoria's BAE Systems manager and also heavily involved in our IMechE Northwestern region, she has had the opportunity to change to an engineering career. She's very proud of that fact, that she's now embarking on a path to become a chartered engineer with the IMechE, and wants to show people that it's never too late to change your career and do something that you feel passionate about. My wife is a primary school teacher, and our son's chosen career is also teaching. Like a stick of seaside rock, if you were to slice through my wife, and I don't intend to do that today, just to reassure her, if you were to slice through my wife, I'm sure you would see clearly the letters teacher running through her. But Victoria didn't feel teaching was the career for her. Her rock letters are engineer. She is thrilled to be part of this institution in the rich engineering heritage that it has, and she loves the fact that she got a second chance, a chance to pursue the career that she wants to pursue, which is engineering. So, Victoria, I know you can't be with us today. If you're listening in on the live stream, I wish you all the best in your chosen career, and it was really great to meet up with you in March. Steering the young generation in the direction of engineering is a critical aspect of our STEM activities. I'm grateful for all the time and effort our membership and staff put behind it, because it is vital to establishing the future pool of engineers that will tackle the next generation's new challenges. As part of my volunteer service for the institution, I've helped to support School Liaison. The institution had the honour to host the Elevating Education event in March, involving Amanda Soloway and Professor Helen James, the chair of our Education and Skills Strategy Board. It highlighted the role of our STEM ambassadors in encouraging more young people to consider engineering as a career. At the institution, we believe education to be fundamental, and we want to inspire our members to get involved and create a positive impact on the next generation. If I may quote our Chief Executive, Dr. Alice Bunn, with 7,500 STEM ambassadors, nearly a third of the UK's total number, we have a huge opportunity to make a positive change and inspire the next generation. IMechE is always looking for passionate STEM ambassadors who will join us on our mission to enthuse young people and showcase the diverse and exciting world of engineering. So if you are interested, I would strongly encourage you to join. An aspect of building the future that I would now like to cover is the future of engineering itself. My wife and I had the privilege to become first-time grandparents in a rather chilly December last year. Naturally, I will do my very best to steer our granddaughter in the direction of selecting the worthy profession of engineering as her career of choice. But what will that profession look like when she's old enough to decide? Well, to paraphrase a well-known science fiction series, the expectation is it's engineering gym, but not as we know it. Peter Flynn, the institution's immediate past president, mentioned this in his own presidential address last year. And I would like to highlight it again, as I think it's a key message that we need to keep hearing. We are living at a time when our technology capacities and capabilities have never been so advanced. The digital era is opening up so many possibilities, and through the rise of Industry 4.0, the mechanical engineering sector is rapidly changing. In the interest of time, I would just now like to bring my presentation to a conclusion. So if I could just summarize in a few words. This year, we look back on 175 years of institution heritage, and we can be rightly proud of what we have achieved. The world is a better place for it. Let us strive to continue working together to create an even better institution. And in the words of our archivist, Lucy Bonner, look confidently towards the future and the next 175 years. I'm grateful to all those who have given their permission for image usage in the presentation today. And finally, I would like to give you a big thanks for listening. I've overrun on time somewhat. My apologies for that. And I believe now, Alice, you will open up a question and answer session.
Fabulous.
Thank you, Alice.
I'm sure I speak for all of us in the room and many, many more online when I thank you on all our behalves for an enlightening, enriching entertaining and inspiring lecture. It was a beautiful meander through history, right through to the next generation. So you did overrun, but that doesn't get you off the hook. We've now got the time for question and answers.
There was method in the madness.
So what we'll plan to do, I think, is take a couple of questions from the room, and we'll then give the opportunity for our listeners online to feed in some questions too. But before we do that, I'm going to use my prerogative to ask the first question, which is quite simply, what are you looking forward to the most?
Oh, that's a really difficult question to answer. I think many things. I think I'm glad that I'm perhaps not in the same situation that Terry and Peter were in terms of the restrictions that were imposed during their presidential years with regard to getting out and meeting people. I am hoping that this year I will have more opportunity to meet the membership face to face. So that would be one priority. And I think just experiencing different aspects of what our membership does, and they do a great job. There's so many hidden stars out there that I would really welcome the opportunity to meet and to learn from their experiences. As you know, why do they do it? Because they have a passion for engineering and they want to contribute something back to the career that they've selected. And I think if I can meet people like that, then I will be really encouraged through the year, and hopefully I can bring some of that back into the institution as well in terms of steering us in the direction forward. Yeah.
Quite right. It's been so wonderful to be able to get out into the regions a little bit more and meet people again. Super. So we've got our roving microphones. Thank you, Lydia. Thank you, Rob. I'd just invite people in the usual way to raise your hand if you'd like to take the opportunity of asking Phil a question. Very good. First of all, I think we shall go in the front here, Lydia, in the middle. Not front, sorry. Here we are. Thank you. John. Thank you to John. Just a few rows back there. Thank you very much for the audience participation.
John Lowe, fellow here. Phil, I want to push on an open door, and that is that in your presidential address, you've stressed the international nature of our institution. I personally embrace and support the view that we are moving towards being a global body rather than a UK body. I recognise that's still a little bit contentious, but that's the direction of travel. What I'm interested in is the specifics. You mentioned that when we ask areas, whether it's Switzerland or whether it's Japan, which is one of our top 3 priorities, that those bodies there look for support from us and maybe don't articulate it. I suggest that the key to support is STEM education for young people. And if we can choose some of the schemes, and some of them are already international, and promote those in those areas, doesn't mean to say we're telling national governments what to do, but we're enabling our branches, if you like to call them, in those territories to be practical. That would be very helpful. And I'd like your views on how we can support our international growth with the suggestion that it's education for young people, STEM, of course.
Yeah, thanks for the question, John. I think STEM and anything we can do with regard to STEM outside necessarily of just the UK approach that we're taking at the moment is something that we should be welcomed. I think we need to think carefully about how that fits into necessarily the process that is actually adopted by maybe other countries. I speak from experience of having adopted or tried to adopt a similar approach in Switzerland. And clearly, the STEM approach that you take there, if you go into the country schools, you have the language issue potentially. So we tried to adopt an approach that went into the international schools where English is the chosen language, and I think we had some success. So I think, yeah, I think we need to be aware that maybe it's not one solution fits all. It needs to be adopted to what works within the local environment, but for sure, I think we need to try and push the STEM activities as much as we can from a global perspective. And I think from an advisory point of view, I think the institution has got some good things that it can share with the local volunteers, the local presence, to try to move things forward in that regard.
Thanks, Phil. It's a very good question. It's that opportunity to scale, isn't it?
Yeah.
Funnily enough, we're having a conversation with the CIBSE president, Kevin Mitchell, who's here with us in the room, about a similar challenge and how we can work together on that. Super. Time for another question in the room. I'm going to go further back. Lydia, Patrick has his hand up. And then we'll come to Ben. I think you had your hand up too, didn't you?
Patrick Knifton, past president. Phil, excellent speech, thank you. Tell me, tell us, what is the proudest moment of your technical career, notwithstanding today?
I've had many proud moments in my career. I think probably the proudest moment in my career was I was asked to head a task force looking at solving a major turbine issue we had in Sweden. My wife will testify that I spent 1 year, I spent more time in Sweden than I did in Switzerland. And there were some real engineering challenges there, and the customer was not at all happy because he couldn't run his turbine at the time because of the issue. And I think working together with the team that we mobilized to address that, and also working together with the customer to actually resolve the issue over a period of about 18 months, and seeing at the end the fact that that engineering solution worked and it delivered for the customer the solution that he needed. I was pretty proud about that and the team at the end.
Wonderful. We shall have to remember to ask Phil the same question in a year's time, I think. Just a gentle reminder to people online, we can take some questions, so if you want to feed any in, please do. But in the meantime, let's go to Ben, who I think had a question too.
Thanks, Alice. As someone who works in the... Ben Mills-Wallace, Young Members Board. As someone who also worked in the power generation sector, I really enjoyed that speech, so thank you, Phil. Recognising that the UK does have a shortage of talent in the engineering sector, and as someone who spent most of their working life living abroad, is there anything you think we could, any lessons learned we could adopt to retain talent in the sector?
Well, that's a really tricky question. I think most engineers are looking for satisfaction in what they do. And if the industry is able to sort of deliver that, so challenges that really motivate engineers to get involved, to feel that they're actually being able to contribute in a positive way to solve those issues, I think is a tremendous motivator. I think different countries have different approaches to try to recognise engineers. My experience in Switzerland is that maybe engineers have got a higher degree of standing there than they maybe do in this country. I think that's an ongoing challenge that we maybe need to try to address. But yeah, engineers, if they're recognised for the contribution that they make, and they do make a significant contribution to society, I think for most engineers, that's the satisfaction that they're probably looking for.
And that's a very noble answer, Phil, and quite rightly so. I did wonder whether you were going to open with a comparison of Swiss and UK engineers' salaries, but no, very good.
No,
very good.
No, I don't want to go there.
So I think we've just got time for one more question, noting that we're now operating under conditions of Swiss punctuality. So if there's one more question in the room, please.
Andrew Ives, past president. Thank you, Phil, for the thought-provoking presentation. Just on that last topic, for many years in the UK, we'd all recognised that both the governments and politicians and the media have not noticed that engineers really do make a contribution to society. But of course that may be changing, and I'd like your views on whether you feel it is changing in the light of the fact that engineers are now one of the major routes to solving the challenges of the planet, and whether your views on how governments in Europe view engineering in that role are different to the UK, or indeed much the same.
Yeah, thanks for the question, Andrew. Well, I'll go back to the part of the response I made to Ben. I do think engineers in Switzerland have a higher standing. I think maybe that's due to the way that the organisation sort of views them, but it's quite clear that some of the major challenges that have been solved in Switzerland in the past, and the rail network is obviously a classic example, have only been solved because of the efforts of engineers to put them in place. And I do feel perhaps sometimes here in the UK that engineers do get a little bit taken for granted. I mean, we are there in the background. We tend not to maybe sort of voice our contribution as verbally as we could do to society. And maybe there's a touch of complacency that may have crept in that is maybe not as strongly present in some of the other countries. But that's a personal reflection. I think it also depends on education processes as well, and it's quite clear that the Swiss education process is not the same as the UK education process. And you have to tackle things, I think, on a different level. If you have a different education process, then you need to think of things that actually address that system as opposed to maybe a system that's working in another country. So that would be my reflection. I hope that sort of addresses the point that you raised, Andrew.
Very good. And I hope this won't be career limiting in any way, but I'm just going to put Swiss punctuality for one side for just a few extra minutes, as we've had an excellent question come in online.
No, by all means.
Which is from Professor Alison Macmillan, who asks, what new or different skill sets do you think young engineers will need for the next 30 years in the engineering workplace?
If I can reflect, there was a section of my that's in the presidential address published version, but I didn't touch on it so much, reflecting on what the IT environment was like when I started as an engineer. And I think probably engineers of today would probably laugh at me if I explained the rudimentary basics of the digital world that we had at that time. And I think the digital transformation is amazing. It is absolutely phenomenal what we can do nowadays using the digital tools that we have available to us. And I think, for me, engineers of today grasping what they can do with that as a tool allows us to actually to be the stepping stone forward into new areas of engineering that will actually grow the future. Almost the sky's the limit in terms of what we can do now with that as a digital tool supporting the industry. And so for me, it would be get grounded in what the capabilities of the digital medium are nowadays. Understand it and apply it to your industry, because that will be the most effective way of us developing engineering into the future.
I'm absolutely sure you're right. Super. So I'm conscious that we are now sitting between yourselves and lunch. So I'm just left to thank you all in particular in the room, also those online for joining us. It's been a really, really wonderful presidential address. I would like to thank in particular Peter and Phil, and I think we should do that in the usual way.